Hi, we're going to do a quick video on factor by grouping with four terms. So this is a four-term expression. That is a requirement for factor with grouping. If this was a trinomial, we would want to turn it into an expression with four terms. But right now we're just looking at this one. So if we have four terms in a polynomial, then what we want to do first is group the first two terms. So we're going to group the first two terms together, and then we're going to group the second two terms together, or the last two. So this is called factor by grouping, and the first step is to group. The next step is to factor out the GCF in each group. So looking at our GCF here, we have 3 and 6. What is in common there? So what is the greatest number that can evenly divide into both of those? And so one trick is to take the smallest and see if it evenly divides into the other term. It does in this case. If it doesn't, you would have to figure something else out. But because it does, then that smaller number is your GCF. Looking at the variables, we have x squared and x. Because there's an x in both of these terms, then x would be part of your GCF. And the trick on this one is that the smaller exponent, just like we picked the smaller number, is going to be your GCF. So we have x to the first and x to the second. X to the first will be part of your GCF. So now that we know that 3x is our GCF in this first set of parentheses, we're going to put that out front, and to make this mathematically correct, we're going to divide each of these by 3x. Now that we've done that, we need to figure out what is the remaining factor on this first set. So 3x squared divided by 3x. The 3's would just give me 1, and x squared divided by x is just x. You're subtracting exponents there. Plus 6 divided by 3 is 2, and our x's are going to actually cancel. So we're done with the first set of parentheses. Let's look at our second group. We have 5x plus 10. Using my little trick, the smaller number is 5. Does 5 evenly divide into 10? It does. So we're going to put that 5 on the outside, and we need to figure out what is our remaining factor. So once we've done that and we determined that 5 is our GCF, we're going to put that in the front and then divide each of these by that 5. Now I want to make a quick note that x is not part of the GCF on this one. GCF is what's in common, and x is not in both of these terms. So you cannot include it as part of your GCF. So let's look at our remaining factor. 5x divided by 5. The 5's are going to cancel. I'll just have x, and 10 divided by 5 is 2. Now I know we're on the right track because what we have here in the parentheses are the same. And if we are doing factor by grouping, that has to happen. These parentheses have to match. If they don't match, you need to go back and reevaluate and check everything because something did not work out right. Okay? Now that we see that those match, that is now our new GCF. So if we look at the whole thing all together, what would be in common with each of these expressions? And you can see x plus 2 is in common. So we're going to just write that out front as our new GCF. And then if we were to take this GCF out, then what do I have left? Well, I have this 3x, so that's going to be part of our remaining factor. And then I have this 5. So we're going to have 3x plus 5. So one more time, this x plus 2 comes to the front, and what is in front of the x plus 2's become the second factor. Now, many people ask me, how come I don't write x plus 2 twice? Well, think about this. Here, I had 5 that really was in both of these numbers, but I only wrote it one time. And if you think about going backwards, you would say 5 times x, which would give you this, and 5 times 2, which would give you this. So that 5's like being redistributed. And you could think about that here. That x plus 2 is going to this one, which is what I have here, and that x plus 2 is going to the 5, which is what I have here. So you only need to write that x plus 2 one time. And that is our remaining factor for factor by grouping.